This is the fifth video where we're using or looking at solutions for the handout using the index refraction handout 1. Question 5 reads, a physicist does an experiment with an unknown substance. She shines light into the substance at an angle of 33 degrees. So our angle of incidence is 33 degrees. She determines that the angle of refraction is 30 degrees. So we write that down because this is what we were told. We know this. How fast is light traveling in the substance? So that is V. We need to know that. What are some other things that we do know? We always know the value of C, which is the speed of light in a vacuum, and that is 3.0 times 10 to the power of 8 meters per second. What else do we know? Nothing else based on what's in the question. There's also another unknown that we don't have, and that's N, based on the formulas that we actually use. There's two formulas that we can use. N equals C over V, and N equals sine I over sine R. So we don't know V, we know C, we don't know N, and we have these two angles. So somehow we have to use these two equations in order to solve this particular problem. Okay, so let's use this one first. Okay, so if we substitute our values, so sine 33 over sine 30, what do we get? So if we take this, hit the sine button and press 33, we get an answer of 0.545 rounded, and then sine 30 gives us an answer of 0.5. So divide 0.5 into 545, so 0.545 divided by 0.5, and we get an answer of 1.09. So we know now that the index of refraction for this particular substance is 1.09. So if you look at what we actually now have, we've got N, we've got C, now we can calculate V. Okay, if you remember from the previous videos, the rearranged form of this particular formula, V equals C over N. And if you want to figure that out algebraically, just refer to the previous video. Now we just substitute the values in, so 3.0 times 10 to the power of 8 meters per second divided by our index of refraction, which is 1.09. Okay, so use our calculator. So 3 exponent 8, so 3 times 10 to the power of 8 meters per second divided by 1.09, and we get an answer of a big number. Alright, so we want to move that decimal place here all the way to here, so it becomes 2.7 times 10 to the power. Well, how many decimal places did we move? 1, 2, 3, 4, 5, 6, 7, 8. 8 places. So it's 2.7 times 10 to the 8 meters per second. That's how fast the light is traveling in this unknown material.